This video highlights some of the features that make the KAS IDE integrated development environment easy to use with a short learning curve. Starting with a pre-done project template saves the user development time. Project starter templates contain code for programming motion and machine code, an internal control panel for developing and debugging programs, and a HMI program to use with the Kollmorgen AKI HMIs. The user can then build on this foundation to complete their application project. Additional axes are added under the motion section of the project. Additional motion blocks can be dragged and dropped from the library. Here an absolute motion function block is added by dragging and dropping from the library. Function block inputs and output parameters can then be added. Additional code to, for example, tie the motion to inputs or outputs, perform calculations, or execute conditional statements can also be added again by dragging and dropping the appropriate function block from the library. New programs and subprograms can be added and code written in one of 5 languages. This allows the user to program in a language they are most comfortable with or one that makes programming the specific functionality the easiest. The ability to create many programs and subprograms allows the programmer to maximize the code structure. The KAS controller can connect to a PLC through digital or analog I/O or through a bus network. Here is an example of implementing an Ethernet IP field bus network to connect the KAS controller to a PLC. Parameters to be transferred can be dragged and dropped from the dictionary into the field bus configuration screen. The IDE supports a similar setup structure for Profinet and Modbus. In addition, UDP and HTTP are supported for communicating with industrial PCs. A field bus can also be used to connect a KAS controller to a vision system, inverter motor drive, or other third-party product. The IDE environment is laid out in an easy-to-understand manner and allows for customization of the home page to optimize it to the user's preference. The IDE supports many data types, including grouping data together into an array structure or a nested array of structures that provide a compact data set to use in the program or transmit information across networks. Here is an example of an array of structures to define various machine parameters. When compiling the project, if a syntax error is found, the compiler output provides error details, and by clicking on that error detail, the place in the code where the error had occurred is brought into focus. Application code can be tested using the simulator. With the simulator, users are able to address motion issues that usually can only be found by running the actual hardware. You do not have to wait for the hardware to be in place and wired up. The IDE contains tools for testing and debugging the code you write for your application. Animation shows the code running to help determine changes for optimization. The 8-channel scope allows plotting of parameters over time to optimize code performance. This plot shows the position changes of axis 1 and 2. Adding breakpoints allows the code execution to be stopped at a specific point in the code. The following shows single-stepping a program written in structured text. Single-stepping allows stepping through a program to show how execution of a single line of code affects things. A watch panel allows grouping specific variables in one place for easy review during program execution. The control panel feature allows using an internal HMI for project test and debug. The control panel can be easily modified. Here we will create a button in the control panel. The button will be used to start the motion of the motion function block we recently created on the main program. KAS incorporates the industry standard EtherCAT network to tie the KAS controller to Kollmorgen servo drives, Kollmorgen AKT remote I/O, and also third-party devices such as an inverter drive. Through features such as offline setup, scanning to find all devices on the network, and drag and drop to connect device parameters to program variables, the integration process is simplified. The Kollmorgen Workbench environment is integrated into the IDE for setting up servo drives, making the IDE a one-stop place to set up both controller and drives. Kollmorgen's AKI HMI terminals are programmed with KVB, Kollmorgen Visualization Builder software, that is integrated into the IDE. Many of the template programs have a complementary KVB HMI program. For example, the project that we have been working with has this KVB program, which we will now open. This HMI consists of operation screens that support the template program, and these are alarm server screen, audit trail, background, fault screen, gear cam move, home start, KVB features, and single axis moves. KVB HMI program can be downloaded into an AKI panel or run directly in KVB. If run directly in KVB with the IDE simulator, no HMI or KAS controller hardware is needed to test both controller and HMI functionality. The IDE contains an extensive help system. In many places in the IDE, information is accessible by clicking on the item, then clicking F1. There are also sections in the documentation with more in-depth theory of operation type information. There is an option to point the help information to an online version that is continually updated by the KAS documentation team. Application notes are also available on KDN. There are also KAS videos on KDN and on the Colmorgan YouTube channel. Last thing to note, the code you developed is forward compatible. Application developed now will work with future IDE releases. In conclusion, the KAS IDE can be learned quickly and has the tools and ease of use features to get you to a final, optimally controlled machine in less time.